once again. Today I want to take you through the topics which you must read before you enter a chemistry paper 2 exam, KCSE exam. So these are the topics that are a sure bet that you must expect. In fact, they will not miss. Therefore, even before you go to an exam room, you must know the topics that are there. Therefore, I'm giving you this topic that I consider the most common topics that you will expect during a paper 2 exam in chemistry. The first topic is organic 1 and organic 2. Organic 1 deals with the hydrocarbons, the compounds with hydrogen and carbon only, and then organic 2 combines both carbon, oxygen, and hydrogen. So you must ensure that you have read, you have gone through all the questions that concern the flowcharts of the organic chemistry. You know the double bond, the triple bond, and the single bond. You know the organic acids, the alcohols. Those are the things you must understand. So that one is a sure bet. It will be there. It will never miss. Question number 2 is metals. A metal cannot miss an exam because actually students don't like reading the metals. Therefore, metals is repeated each year. Every year, metals are there. What about electrochemistry? Electrochemistry is another topic which will always be there. Electrolysis, the electrochemical cells, that one will not miss. Therefore, these are the marks. In fact, paper 2 is the cheapest paper that every student should get at least 60 out of 80 because you know the topics. These are the topics. It can even take around 5 hours. You read them, you do them, and then you will score, you will change your grade in chemistry. The next one is salts. This we have a flow chart for salts, so you should also read for salts in form 2. You should understand salts, effect of heat on salts, carbonates, all those things, you must know them. Another question that you must expect is the processes that are used to manufacture different gases, different acids. The HAPA process. The HAPA process is used in the manufacture of ammonia gas. So you should know the raw materials, the impurities which are removed in the HAPA process, the raw materials, the impurities, the catalyst that is used in the HAPA process. Those are the things you must read and get them right. You should know the reaction in the catalytic chamber. You should see that process coming, and you should have it in your fingertips in short. The next one is the Solvay process in form 2, where we manufacture sodium carbonate. So that one you should also have it in your fingertips if you really want to score marks in paper 2. Another process that you must know is the contact process. The contact process is the industrial manufacture of sulfuric 6 acid. So in sulfuric acid, you must know the raw materials, the catalyst used in the contact process, the why impurities are removed, the reaction in the catalytic chamber. You should know all of those things. Oleum, the reaction where oleum is taking place, why sulfur 6 oxide is not directly dissolved in water. It is first dissolved in sulfuric acid and then diluted later in the dilution chamber. So those are the things you must know before you go to an exam room paper 2. And also you should know the reason why the sulfur 4 oxide is not allowed to go to the atmosphere. What process is that is used to prevent sulfur 4 oxide into the atmosphere? Scrapping. You must know what is scrapping. How is the equation of scrapping written? Those are the things you must know. Another process that you must know before you go is the Ostwald process. The Ostwald process is the industrial manufacture of nitric acid. So with the Haber process to give you one flow chart, therefore you should know that. Another free 10 to 12 marks is the periodic table. That one is a sure bet. You should be sure of this. There is no day exam has been set and there is no questions of the periodic table. Periodic table involves the questions in topic 1 in form 2, the structure of the atom, topic 2, which is the chemical families, and topic 3, which is the structure and bonding. Therefore, these 3 topics form the periodic table actually. Therefore, you must expect 12 marks or 10 for the periodic table. So that's why I have seen, because that one I'm sure it will be there. Therefore, I have decided to take you through a question in the periodic table. So let us go and look at it. Down here, there is a question here I want us to study. The grid below is part of the periodic table. Use it to answer the questions that follow. The letters do not represent the actual symbols of the element. So that's the question. You always find that. Now this is a simple periodic table that, as you can see it. So for you to answer the questions in the periodic table, you must master the periodic table. You must, now this, for example, this, so this periodic table, simple periodic table, you should know that this one, the first square here is atomic number 1. So you should first write those atomic number, write them atomic number 2, atomic number 3. So because you cannot answer these questions unless you know the atomic numbers. So this is atomic number 4, atomic number 5, like that up to the end. So once you have written the atomic numbers from 1 up to 20, now you should be able to, you will be able to know what you are doing. Remember, the first square is for hydrogen, the second square there is for helium, and then beryllium, lithium, boron, and then we go to carbon, like that, nitrogen, all the way to calcium, atomic number 20. So once you know that, you should know these elements represented by Z, what they are called. So let us go to the question and see what they are asking. Indicate on the grid the position of an element represented by a letter V whose atomic number is 14. An element number which is atomic number 14, therefore you should be able to count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So 14 is here. It means that this element is supposed to be there. So this is the element which is atomic number 14. Because, you know, if you don't know how to count this one is going to be difficult for you to give it. So we have answered that. Next question is, select a letter which represents a monoatomic gas. A monoatomic. We have diatomic gases like hydrogen is a diatomic, oxygen is a diatomic, chlorine is a diatomic. But we have group 8 gases, they are monoatomic. That is neon, helium, they are monoatomic. So in this case, U is a monoatomic gas. In this case, we have U, they have atomic gas. Because, you know, group 8 gases, group 8 elements, most of them are gases. Helium is a gas, argon is a gas, and argon is just written Ag. Argon is Ag. AR, sorry, AR, a small r. So you can see they don't have the two like we have in chlorine or in oxygen. They are just monoatomic. Mono means one atom. Yes, monoatomic. Write an equation for the reaction between Q and T. So before you write, go to Q and T. What is element Q? You should know that this is element, this element, and that element. So Q, this is atomic. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Q is atomic number 12, right? Q is atomic number 12. So if Q is atomic number 12, that's magnesium specifically, and then T is chlorine, that is atomic number 17. Therefore, Q is magnesium. So Q is, I think this one is right. This why we use this answer. Somebody used aluminium. It should be magnesium because Q is atomic number 12. So write an equation. So the equation you can write either using the letters provided, or you can use the real element. So this one should be magnesium. 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 I don't think this one is going to be there. Plus chlorine, which is going to give us magnesium chloride, and this one should be 2. So magnesium chloride, and this is the chemical, the equation for the reaction. Because you have been asking the equation, you included the status. Magnesium is a solid, chlorine is a gas, magnesium chloride is a solid. This one, now we can change this one. You can remove this Q and remove this like this, and then remove this like this, and then you put 2 here. If you want to use these letters, then make sure you do like that. Now this one is, you have written the equation the way it is expected, then ensure you write the status. So the most important is to understand the periodic table. Whenever you must know that the first one is hydrogen, and that is atomic number 1, then you write the atomic numbers. That will, so by now you should know that U is atomic number 18 and P is atomic number 19. Explain why N and Q would not be expected to form a compound. N and Q. N is a metal. Actually, it is sodium. Q is another metal. Actually, that one is magnesium, we have said. There is no way a metal and a metal can react. So that one we should know. Therefore, we don't expect a compound there because they are both metals and need to lose electrons. So there is none of them will gain electrons. Therefore, they need to lose. Therefore, they will not react because they are both metals. To which period and the group of the periodic table does element Q belong? Q. So for you to know the period and the group where Q belong, you must write the electron arrangement, electron configuration of Q. For example, Q, it is atomic number 12, we have said, so therefore it is 8, 2.8.2, right? So once we have written the electron configuration, now you can be able to group this element. That tells us that the outermost energy level, there are 2 electrons, there it means it is group 2. It has how many electrons, many energy levels? 1, 2, 3. Therefore, it is period 3. So Q is the electron configuration is written here, right? And then it is group 2 because it has 2 electrons in the outermost energy levels. So it is in group 2. Has 2 electrons in the outermost energy level, and a period 3 because it has 3 energy levels. How do you know it has 3 energy levels? You count. The first one is, the first energy level is 2, the second energy level has 8, the third has 2, so the total is 12. So that's how you know. So for you to know the group of an element, the period of an element, you must write the electron configuration of that element. For you to write the electron configuration of that element correctly, you must know the atomic number of that element. How does the atomic radius of N compare with that of Q, the atomic radius? Explain. So let us go to N and Q, see the relationship between them. N and Q. N and Q across the period. You can see N is 11 and Q is 12. So what is the relations? What happens across the period? What happens to the atomic radius across the period? So those are the things we run. So you should know that across the period, the atomic radius decreases. Mark that. Across the period, the atomic radius decreases because of the increase in the number of protons, right? As the number of protons increases, because across the period the atomic number is increasing. This is 11, 12, 13, 14, 15, 17, 15, 16, 17, 18. So across the period, period 3, that is, the atomic number is increasing, the number of protons are increasing. So therefore, across the period, there is an increase in the nuclear charge. Remember, the nuclear charge is the force that is holding the electrons in the outermost energy level. So if the nuclear charge is increasing, it means the outermost energy level are strongly held towards the center, towards the nucleus. Therefore, the atomic radius decreases because the outermost energy levels in U are strongly held by the nucleus, because across the period the nuclear charge is increasing because the protons are increasing. Remember, the protons are found in the nucleus. Therefore, how does the atomic radius of N compare? So we can say that Q has a smaller atomic radius than N. Q has a small atomic radius than N. That is very correct. So we can say that, is it, which one we are comparing? Sorry. Oh, this one is for P. I think I've answered a different question, but it's okay. We are talking about N, I think it is this one. P, how does the P and N? I think there is a... So we have answered this. How does the atomic radius of N compare with that of Q? We have said that N and Q is across the period. Therefore, the answer is Q has a small atomic radius compared to N. That is correct. Q has a small atomic radius compared to N. This is because Q has more protons. So the nuclear charge is higher, hence attract outermost electrons more strongly. So you should know that across the period, the atomic radius decreases. Why? The number of protons increases, therefore the nuclear charge increases. The responsibility of the nuclear charge is to attract the outermost energy levels. So if the number of protons increases, the nuclear charge increases, and it holds the outermost energy levels strongly as you move across the period. Very correct. The next question of a similar is, how does the atomic radius of N compare with that of P? So that one was across the period. What about down the group? How does the atomic radius of N and the P compare, these two? Which one has higher atomic radius and a smaller atomic radius? So P has a larger atomic radius compared to N, because down the group there is an increase in the number of energy levels. Therefore, atomic radius increases. Atomic radius increases. Larger atomic radius compared to N, P has more number of energy levels. Since down the group, atomic number increases. Therefore, down the group, the number of energy levels increases. Therefore, the atomic radius will always increase down the group. What type of bond would be present in a compound formed between T and Q? Explain. So you go to the periodic table and check between Q and T. So Q is a metal. T is chlorine and an metal. So the bond between a metal and a non-metal is ionic bond. In ionic bonding, there is complete transfer of electrons. Therefore, the bond between Q and T is a ionic bond. Here, this is this is a bond between a metal and an animetal. Therefore, there is complete transfer of electrons from one element to another, and you have explained, you expect your 2 marks. The answer is ionic bond. Remember, the bond between an animetal and an animetal, like oxygen and carbon, it is a covalent bond, except for carbon 2. Carbon 2, we have dative bonding. You should know that. Thank you. What name is given to a group of elements to which S and T belong? Another way of asking this question is that, what is the name of the chemical family to which S and T belong? So let us go to the table and check S and T, which, so we have S and T. So S, so we can now see this is group 1, group 2, 3, 4, 5, 6, 7. So S and T are found in group 7. What is the chemical family given to group 7 elements? This one is called halogens. You should know that. So group 7, S and T belong to a chemical family called halogens. Group 1, we call it alkali metals. The group 1 metals are given the name alkali metals. Group 2, this one, group 2, they are given alkaline earth metals. Group 2 elements are called, the chemical family or the chemical name for group 2 is called alkaline earth metals. Make the difference between group 1 and group 2. People confuse a lot between group 1 and group 2. Group 1, they are called alkali metals. Group 2, they are called alkaline earth metals. Group 7, they are called halogens. So you write that group 7, these are called group 7 and they are called halogens. They are just called halogens. Therefore, that is the chemical name for group 7 elements, halogens. Give the name to element Z. So element Z. These are elements which are not in the small periodic table. We call them transition metals or transition elements. Don't call them transitional. They are not transitional, but if you write transitional, be sure that you will get it wrong. It is called, this element Z, they are called transition elements. Transition elements. Elements or metals, so it's accepted. Element U is generally unreactive. Explain. Which one is that element U? You come to the periodic table. Element U is found in group 8. This is group 8. Group 8 elements don't react. Why? They are stable. They neither lose electrons nor gain electrons. They don't gain, they don't lose. Therefore, they are stable. Why are they generally unreactive? It is because they neither gain electrons nor lose electrons. Therefore, they are stable. They don't react. Element U neither gains nor lose electrons because it is stable, hence unreactive. Using dot and a cross to represent outermost electrons, draw a diagram to show the bonding in the compound formed when M and R react. You must know. So let us count 1, 2, 3, 4, 5, 6. 6 is carbon. 7, 8. AR is oxygen. So this is the compound that is carbon plus oxygen. You should know that carbon plus oxygen, this is an animetal, therefore the bond is covalent. Therefore you should know how to draw a covalent structure where they are going to share electrons. I may not draw now, but you should know how to draw. But I have done that in my video, which is there in the YouTube. So this is the kind of question you need to expect in paper 2. This is the question which you will not miss there. So make sure you go through the revision of the periodic table, make sure you know. Another thing you must know is to compare the atomic radius and the ionic radius. For example, you can be asked, how will you compare the atomic radius of N, the atomic and ionic radius of N? So you should tell us that the ionic radius of N is either smaller or bigger, and therefore you should know those things. How does the ionic and atomic radius of Q compare? Explain. If it is halogens, how does the atomic radius and ionic radius of T compare? You should know that. Down the group of halogens, which one is the most reactive and which one is the least reactive? How does the ionization energy of the halogens compare down the group? How does the ionization energy across period 3 compare? Therefore, those are the things you must learn and be aware as you prepare for your exams. Therefore, I wish to stop here as I give you more time to revise for your exams. Thank you very much. Thank you. Remember to subscribe.